I think this is my third video on limits. We'll call it a part 3. I think we'll call it intro to limits. All right, like I said, I only have 4 more examples, and I believe this one is example 9. Is that right? Was y'all's last one 8? Okay. The last one was 9. Was it the square root of x plus 10 over x minus 10? Oh, okay, so this would be 10. All right, what is the limit as x approaches 9 of the square root of x? I've got plus 10 that's not under the radical, quantity divided by x minus 10. All right, if I start with direct substitution, is that going to give me a 0 in the denominator? No. We're used to it being a yes, right? So, I mean, because you're probably going to go, well, I'm going to have to do the conjugate of the square root of x plus 10. But because if I substitute this 9 in direct substitution, I won't get a 0 in the denominator, so I don't need to go through all that. We'll just go straight to direct substitution. So that is the square root of 9 plus 10. Make sure your plus 10 is not under the radical, over 9 minus 10. Well, square root of minus 3, so 3 plus 10 over 9 minus 10 is negative 1. That gives me 13 divided by negative 1, which is negative 13. Boom. Started off with an easy one. Everybody cool with that? Wish that happened every time, but it doesn't. Example 11. What is the limit as x approaches 1 of x squared minus 1 over x cubed minus 1? Can we start with direct substitution? No, because 1 cubed is 1 and 1 minus 1 is 0. That gives us 0 in the denominator. We can't do that. Okay, well, let's try to factor, right? So let's see, what is the limit as x approaches 1 of x squared minus 1? That's a quadratic, but it's a special case. What is that called? Difference of squares. Super easy to factor a difference of squares. Perfect square minus a perfect square. Make 2 sets of parentheses. Put a plus in the middle of one set, a minus in the middle of the other. The first term in each set is the square root of the first term. What's the square root of x squared? X. The second term in each set is the square root of the absolute value of the second term. What's the square root of 1? 1. X cubed minus 1, the denominator. Is that also a difference of squares? What is that? Difference of cubes. We factor that one differently, right? It's easy, but it's not as easy as difference of squares. Let me do it over on the side. Difference of cubes. Remember, that follows a pattern. If you have a perfect cube minus a perfect cube, such as a cube minus b cube, the first set of parentheses is a minus b. That's the cube root of the first term minus the cube root of the second term. Remember, if it's a sum of cubes, that would be a plus b, right? Sum of cubes is different. Second set of parentheses, you take the first term in the first set of parentheses and square it, plus multiply these two together, just not the absolute value. So a times b is ab, plus the second term in the first set of parentheses squared, so plus b squared. So A is referring to the cubed root of the first term. What's the cubed root of the first term? X. B is referring to the cubed root of the second term, the absolute value of the second term. And what's the cubed root of 1? 1. So now that I know A and B, I'm going to plug it into this pattern, okay? So for my first set of parentheses, it's A minus B, so X minus 1. Second set of parentheses, A squared, well, that would be X squared. Then it says to add A times B, in this case, X times 1 is X. Then it says to add B squared, well, 1 squared is 1. Now we're hoping that X minus 1 will cancel, because that's the reason we can't substitute in, do direct substitution, right? Is it going to cancel? Yeah. X minus 1 and X minus 1 cancel. So what is the limit as X approaches 1 of X plus 1 divided by the quantity of X squared plus X plus 1? Now, I don't even care if I can factor X squared plus X plus 1. I don't care. Because if I can use direct substitution and not get a 0, then I don't care if I can factor it, which is not factorable, but I don't even have to worry about it. So if I plug in a 1 in denominator, will I get a 0? No. Okay, so let's go to direct substitution. So numerator, 1 plus 1.
Miss Rayleigh?
Yes?
When, since A squared minus B squared, B cubed is for A squared plus AB plus B squared, shouldn't X be negative? Because it's negative 1.
The signs that you use when you have a difference of cubes, you use, in the first set of parentheses, it's going to have a negative between them. In the second set of parentheses, it's both going to be positive every time. This is like, it's called an identity. And those are the signs. Think of that as the absolute, so B, this is the absolute value of the second term. Because I know the second term is technically negative 1, right? This is the absolute value of the second term. And your signs are going to be whatever they are in this identity. If you had a sum of cubes, it's A plus B times A squared minus AB plus B squared. So there's an identity for both. And we did a whole lesson on this. I don't know when it was, what module it was. I'll have to go search for it. But there's a whole video on factoring sum of cubes and difference of cubes if you need more help, okay? All right, so the denominator, we have 1 squared plus 1 plus 1. So that gives me 2 over 1 plus 1 plus 1. Final answer, 2/3. When y'all do your assignment for this, if you put a bubble around your answer or a square or like highlight it with a different color or something, because I got to search through all this to figure out what your answer is, just make it obvious, that would be very helpful. All right, example 12. Last example. If you've been absent for any of the notes on limits, I would go watch the video before trying to do the assignment, because there's so many different types of problems. Okay, so if you missed, this is going to be the 3rd video. We posted, let's see, Friday we did the 2nd video, Thursday we did the 1st video. So if you're absent Thursday or Friday, make sure you watch those before trying to do the assignment. Example 12. What is the limit as X approaches 2 of X cubed minus 2X squared plus 4X minus 8 over X to the 4th minus 2X cubed plus X minus 2. If I plug 2 into the denominator, direct substitution, I would get 0. So I can't do that. All right, well, I'm gonna have to see if I can factor these. Neither are quadratics. Okay, well, we've done factor by grouping before, but I don't think we've done it a lot, so that's why I wanted to include this problem. A lot of y'all learn how to factor quadratics using factor by grouping, so this will probably seem familiar to you if that's the case. But when you see 4 terms, try to do factor by grouping. Not everything is factorable that way, but when you see 4 terms, try to do factor by grouping. So I'm going to start with my numerator. When you do factor by grouping, you group your first 2 terms together, you group your second 2 terms together. Okay? In the first, and when you do this method, if your GCF, if all you have is a 1, usually we don't factor out a 1. But When you're doing factor by grouping, if that's your only common factor, then that's what you factor out. So look at your first two terms. What is the GCF? X squared, right? It can be a variable or a number or the product of a number and a variable. Well, my coefficient of x cubed is 1. My coefficient of negative 2x squared is negative 2. So that would be a 1. But x cubed has 3x's, x squared has 2x's. They both at least have 2x's, so I can factor out x squared. So to see what's left, factor out a GCF of x squared from both terms. So we just divide to see what's left. What's x cubed divided by x squared? X. If I went back and multiplied, x squared times x, I get x cubed. What's negative 2x squared divided by positive x squared? Negative 2. Now, in your second group, you need a sign, positive or negative, okay? Whatever the sign of the first term is, that's going to be the sign you factor out. They don't both have to be positive. They don't both have to be negative. Whatever the sign of the first term in the second group is, that's what you use. And what's the GCF of that group? 4. So I'll divide, so the GCF is positive 4. I'll divide both terms by positive 4. So it's positive 4x divided by positive 4. X, what's negative 8 divided by positive 4? Minus 2. Does this look familiar to y'all? Okay. If what is inside the parentheses is identical, that means it's factorable. If it's not identical, you either did something wrong. If you didn't do anything wrong and they're not identical, then it's not factorable. Okay. So first check. If it's not the same, check to see that you do something wrong. Because a lot of times, like if this sign is negative and you're supposed to factor out a negative, but you didn't divide both terms by the negative, and then it's going to throw it off. Like that's usually what happens. All right. But if it's identical, it's factorable. Make 2 sets of parentheses. What is identical is a common factor to both groups. So we factor it out. That's why it's only written once, because it's the GCF of both of those groups. What's left on the outside, the x squared and the positive 4, you group those together in the other set. Now, x squared plus 4, is that a difference of squares? No, that's a sum of squares, plus, right? That does not factor to x plus 2 times x minus 2. If it's x squared minus 4, that would be a difference of squares. You can factor it further. But it's a sum of squares, so we don't factor that. That can't be factored using real numbers. So my numerator factored out to be x minus 2 times x squared plus 4. Well, that doesn't cancel with anything in the denominator. Can I cancel that x minus 2 with that x minus 2 in the denominator? No, because it's not factored. That's standard form. You can't do that. You gotta factor it. See what you got. You know, like a crazy lady. So I can see the denominator is not a quadratic. So I can't use t-term divide and slide and all that. It does have 4 terms. So maybe we can factor it like we just did what was in the numerator. 4 terms. Try to do factor by grouping. Group your first 2 terms together. Group your second 2 terms together. Usually if the GCF is 1, you don't factor it out. When you're doing factor by grouping, if that's all you can factor out, you do. So my first group, what's the GCF? X cubed. So you're going to factor out an x cubed. To do that, divide both terms by x cubed. What's x to the 4th divided by x cubed? X. What's negative 2x cubed divided by positive x cubed? Minus 2. What is going to be the sign of the GCF of the second group? Positive. It's whatever the sign is of the first term in the second group. What is the GCF of the second group? 1 is all you have. And you're like, well, why do you factor out a 1? You never factor out a 1 if that's a GCF. Well, when I'm factored by grouping, I need 2 terms and both sets of parentheses. Okay? And you got to have signs in the middle of them. So if I divide by positive 1, what am I left with? X minus 2. Is this factorable? Yes. If what's inside parentheses is factorable, make 2 sets of parentheses. There's 2 products here. The GCF of those 2 products is x minus 2. That's why it's only written once, because it's the GCF. What's left on the outside? X cubed plus 1. Now listen, x cubed plus 1 is a sum of cubes. I can factor that further. However, my x minus 2 is going to cancel out, correct? So if I cancel that out, if I plug in a 2 at x cubed plus 1, am I going to get a 0? No, so there's no sense in factoring that out. I don't need it to cancel to use direct substitution, okay? So that's why I'm not factoring x cubed plus 1 any further, because it's not necessary. You could, but it's not necessary. So what is the limit as x approaches 2 of x squared plus 4, quantity divided by x cubed plus 1? Again, x cubed plus 1 is a sum of cubes. I can factor it, not necessary, because I can now do direct substitution, and I won't get a 0 in the denominator, so there's no sense in factoring it. Numerator 2 squared is 4, so I have 4 plus 4. Denominator 2 cubed is 8, so 8 plus 1 gives me 8/9. That cannot be reduced. That is my answer. Y'all good with that? All right. So I'm going to stop my video, and I'm going to put up the assignment, okay?